At the core of the decision tree algorithm is choosing the feature to split on. And that's the place we're going to modify to also choose what to do with that missing data. Recall that the most important question in decision tree learning is figuring out what feature to split on. And so now, when we look at what feature to split on, we're not just going to decide what feature to split on, but we're also going to decide which branch to take when we see a missing value. And so conceptually, it's just a very, very simple modification of the algorithm we described in the previous module, but now we're just going to add this extra search to figure out where to put that missing data. Just like with greedy learning of decision trees, we can just focus on learning decision stump to understand what's going on here. So we chose to split on credit. Credit can be excellent, fair, or poor. And the branch here on the right is the one where all the data points have credit equals poor. And now we might decide that the missing data is going to go into that branch. So now we're going to take all the data that was missing and the data where credit was poor and feed it into that particular node. That's what's going to happen with categorical data. Now, when we have numeric data, we're going to use those threshold splits that we discussed in the previous module. And in this case, we might threshold income as less than $50,000 or greater than $50,000. And if we might decide that missing data or data where the income is unknown, we're going to feed it to the same node where of those that the income was less than 50,000. That's the decisions that we're going to try to make inside of our learning algorithm. Now we have to decide where missing data is going to go. So let's say that we choose to split on credit. We're considering splitting on credit. If we're considering splitting on credit, what should we do with the missing data? Should we put it with people with excellent credit, for people with fair credit, or with people with poor credit? I don't know what's best, but we have a principle for dealing with this. It's a principle that says choose the branch that leads to the lowest classification error, just like we did before. Let's say that we're considering splitting on credit, and we're considering assigning the missing data to the branch where the credit was excellent. Let's see what happens. So in this example, we have 3 data points with missing data, these 3 here, and we're considering assigning those data points to the branch where the credit was excellent. So we had 2 kinds of data. We had the observed data, and in there we have, in the excellent branch, we have 9 safe loans and 0 risky. In the fair branch, we have 8 safe loans and 4 risky. And in the poor branch, we have 4 safe loans and 12 risky. Now, we have these 3 extra data points, and in these 3 extra data points, as you can see, there's 2 risky and 1 safe. So we're thinking about adding this 2 risky and 1 safe into the excellent branch. So what are the grand totals here? The grand totals are 10 safes and 2 risky inside the excellent branch, and then the same for the other 2 branches because we're not adding any extra data. So what's the overall total error of the resulting decision tree? Well, for the excellent branch, we're going to predict safe, so we're going to make 2 mistakes. For the fair branch, we're going to predict safe, so we're going to make 4 mistakes. And for the poor branch, we're going to predict risky, and we're going to make 4 mistakes. So overall, we're going to make 10 mistakes, and our total was 40 data points. So the total error here is 0.25, 1/4. Now, we do the same for every single option, every single branch. So we tried putting the unknown data with the excellent and got error 0.25. If we tried to put it with the fair branch, we'd get 0.25 error as well. But if we try to put it with the last branch here, with the poor branch, we'll get an error of 0.225. And so that's a lower error, so this is the winner. So the best thing to do would be to assign unknowns to the poor branch, to credit equals poor, which is exactly what we did in the earlier tree. This is the modification of the tree splitting algorithm to take into account missing data. It gets a little, complicated, but it's generally kind of simple idea we just described. We'll leave it here for a reference if you choose to implement it. But overall, the fundamental concept is you can use this idea of embedding handling of missing data inside of the learning algorithm to get better overall performance.